Hello, today we will be doing the solubility part of water chapter. What is solubility? Amount of solute that dissolves in 100 gram of solvent, this is very important, to form a saturated solution at a particular temperature. These two conditions are very important. One is 100 gram of solvent and at a particular temperature. Like NaCl dissolves in 100 gram of water. At 40 degrees Celsius, the mass of NaCl dissolved is 36.5 gram, and at 40 degrees Celsius 63 grams of KNO3 potassium nitrate is dissolved in 100 gram of water. So at 40 degrees Celsius the solubility of potassium nitrate is more. Potassium nitrate solubility is 63 gram and sodium chloride solubility is 36.5 gram. So these two conditions, mentioning these two conditions while writing the solubility is very important one. So the definition is the solubility of a solute in a particular solvent at a given temperature is equivalent to the maximum number of grams of the solute necessary to saturate 100 gram of that solvent. So the solubility of a solute in a particular solvent. So the solubility of a solute varies with the nature of the solvent, with the temperature. At a given temperature is equivalent to the maximum number of grams of the solute. Matlab, how much gram of solute will be dissolved to make a saturated solution where the solvent content is 100 gram at a particular temperature. Now, what is insoluble substance? A substance that has very negligible solubility is called insoluble. Example, silver chloride. It has 0.000015 gram as its solubility. On the other hand, there are some sparingly soluble substance which has more than negligible but less than high solubility. Like calcium hydroxide, it has solubility 0.17 gram, and the soluble substance like sodium chloride, it has high solubility. So this is called high soluble. Now what are the factors affecting solubility? First is the size of solute particles. Smaller the size of the solute particle, greater is the total surface area exposed to the solvent. So the greater will be the solubility of that solute. The smaller the size, higher is the solubility. Stirring will increase the rate of formation of the solution. If you stir, more solvent will be in contact with the solute, so there will be the rate of increase of formation of solution will be increased. Third and most important point is solubility at temperature. Solubility of a gas in liquid decreases with rising temperature. This will be separately discussing. And solubility of most solids in water usually increases with rising temperature, but there is a variation. Now example, the solubility of potassium nitrate in water at 20 degrees Celsius is 31.6 grams, whereas if you increase the temperature to 60 degrees Celsius, the solubility is 108 gram. Now once it is solubility, it is in 100 gram of water. So these factors affect solubility because in the process of dissolution, the particles of solute merely occupy the spaces between the particle of the solvent without any chemical change. Now variation in solubility of a given substance with temperature can be shown by solubility curves. So what is a solubility curve? A solubility curve is a line graph that plots changes in solubility of a solute in a solvent against changing temperature. We will see this. The y-axis or ordinate solubility is plotted, and along abscissa or x-axis temperature is plotted. Temperature is shown in degrees Celsius. These are the variation. Like if you see, potassium bromide varies directly with the temperature. In case of sodium chloride, there is very little variation. In case of hydrated calcium sulfate, first it is increasing, then it is decreasing. So these are the different nature of solubility in 100 gram of water for a particular salt. Now substances like sodium nitrate, potassium nitrate, potassium bromide, sodium nitrate, potassium nitrate and potassium bromide, these show considerable increase in their solubilities with rising temperature. And solubility of NaCl. Solubility of NaCl increases very little with the rising temperature. Next, whatever I have said, that is calcium sulfate, hydrated calcium sulfate. It is CaSO4.2H2O written over here. So solubility of hydrated calcium sulfate show that there is a decrease after attaining approximately 50 degrees Celsius temperature in their solubilities with further rising temperature. So if you increase the temperature, first it increases and then decreases. There is an anomalous solubility found in globus salt. Here the solubilities first increase and then decrease. Now in case of globus salt, the solubility first rises up to 32.8 degrees Celsius, then it falls, because globus salt or Na2SO4.10H2O is hydrous below 32.8 degrees Celsius and it loses all water at 32.8 degrees Celsius and becomes anhydrous. So now if you go through an endothermic process, the solubility of solute increases with increasing temperature. Like sodium nitrate and potassium nitrate solubility increase with rising temperature. Whereas in exothermic process, solubility increases on lowering the temperature. Examples are calcium sulfate and calcium hydroxide in water. The solubility of these two salts decreases on increasing the temperature. Now, use of solubility curves. The uses are to determine the solubility of a substance at a particular temperature, and the effect of cooling of hot solutions of different substances can be found from the curve. For example, on this second point, there are certain problems solved. When a saturated solution is prepared at 40 degrees Celsius and then it is cooled to 15 degrees Celsius or lower than 40 degrees Celsius, some salt will be precipitated out because the solution is saturated at a particular temperature, that is 40 degrees Celsius. If you cool the solution, some solute will be precipitated out because at that temperature, let's say you cool to 20 degrees Celsius. So at 20 degrees Celsius, the solubility of the salt is different. So some salt will be precipitated out. Next you go to the salt example number 1. So there it is mentioned 12 gram of a saturated solution of potassium chloride at 20 degrees Celsius when evaporated to dryness leaves a solid residue of 3 gram, and calculate the solubility of potassium chloride. So how much was the saturated solution weight? It was 12 gram. And the temperature is mentioned, that is 20 degrees Celsius. Now, it is evaporated to dryness. So, when it is evaporated to dryness, there is a solid residue formed. That means the 3 gram of potassium chloride was there in the saturated solution. So, first find out the weight of water. So, it is coming as 9 gram. Sorry. As per the definition, we know that solubility has to be expressed in terms of 100 gram of water. Means how much solute is present or dissolved in 100 gram of water. So now from this you can find that 9 gram of water dissolves 3 gram of solid, that is potassium chloride. So 100 gram of water dissolves how much solid? We will be finding 33.3 gram solid, that is potassium chloride. So you will be writing the answer as solubility of KCl or solubility of potassium chloride in water at 20 degrees Celsius is equal to 33.3 gram. Now once you write solubility is 33.3 gram and mentioning the temperature, it means that it is in 100 gram of solvent. Here it is water, because potassium chloride dissolves very easily in water. Second example, there are two solubility values are given at different temperatures. See the solubility of sodium nitrate. Now they have asked the question, find the weight of sodium nitrate required to prepare 60 gram pure crystals from its saturated solution at 70 degrees Celsius. Means from the saturated solution of sodium nitrate you have to prepare 60 gram of pure crystal at 70 degrees Celsius. And the solubility is given. Solubility of sodium nitrate is 140 gram at 70 degrees Celsius. Means 140 gram of sodium nitrate dissolves in 100 gram of water at 70 degrees Celsius, and 100 gram is the solubility at 25 degrees Celsius. Means 100 gram of sodium nitrate is dissolved in 100 gram of water at 25 degrees Celsius. So if you cool from 70 to 25 degrees Celsius, you will be getting the crystals of 40 gram, because you know once the saturated solution is prepared at some higher temperature and is cooled to the lower temperature, certain amount of salt will be precipitated out. So the salt precipitated out is 40 gram. Now you have taken 140 gram of solution. 140 gram of sodium nitrate in the solution at 70 degrees Celsius, and you have obtained 40 gram of crystal. So to obtain 40 gram of crystals, NaNO3, that is sodium nitrate, was taken is 140 gram. See the solubility, means 140 gram of sodium nitrate dissolves in 100 gram of water at 70 degrees Celsius. That is the solubility. So for obtaining 40 gram of crystal, when you have cooled, the sodium nitrate taken was 140 gram. So if you want to get 60 gram of crystal, how much sodium nitrate will be required to take? So that is coming as 210 gram. So the answer is, for getting the pure crystal of 60 gram, the weight of sodium nitrate required is 210 gram. Thank you for patience hearing. Thank you.